All right, we're starting section 6.3, which is 8.4 in the old book. We're learning how to change complex numbers into polar representations, which is interesting. The reason we're going to do that is because it allows us to do cool things with them a little easier, like multiply, divide, not add and subtract, but multiply and divide and powers and things like that, which we will learn about in section 6.4. Okay. So here's a complex number. If you don't remember this from Math 1050, our complex number is being labeled with the variable z for some weird reason. And then we have the real part of it is represented by A, and the imaginary part is represented by B. So we might see this notation where it has RE of z is meaning the real part of the imaginary number, and then the IM of z is asking us for the imaginary part of the imaginary or complex number. So then we can graph these in what we call a complex plane. So for our complex plane, this is our real axis right here, the x-axis, and then this axis up here is the vertical one, the y-axis is the imaginary axis. And what we end up doing is we're going to graph the point A comma B. So it's going to be the real number is like the x value going left to right, and the imaginary part is the y value going up or down. So let's go ahead and experiment with a few of these. Z sub 1 is what I've named it, is going to be the complex number -4 plus 2i. So the real part is -4, so I'm going to go left 4, 1, 2, 3, 4, and then the imaginary part is 2i, so we're going to go up 2. So left 4, 1, 2, 3, 4, up 2, puts our point at about right here. So that is Z1, which is the imaginary or complex number -4 plus 2i, and we've graphed that at the point -4, 2. Does that make sense? So if we wanted to graph the point Z sub 2, that would be real part 1 and imaginary part is 0. So real part would move to the right 1, imaginary part would be up or down 0. So that would be our Z2 point right here. And then Z3 has 0 for its real component and -3 for its imaginary component. So left or right, 0, and then down 3 would be that point right there. Okay, any questions on how to graph complex numbers? I'm looking at the chat, but it looks like Adrian's just giving technical help. So, okay, let's learn some fancy words for things we already know about. So with complex numbers, we're going to talk. Okay. With complex numbers, there are two words you need to know about as you're changing those to polar form. The first one is the modulus. It's a fancy word for the radius or the hypotenuse. It really just means the distance of the complex number from the origin. So when we find the modulus of a complex number, we're finding its distance from 0, basically. So I've actually seen questions on sample ACTs that have this kind of terminology in them. So obviously we're using Pythagorean theorem to go ahead and find that modulus. Okay, and then the other item that's important with changing these to polar coordinates is what we call the argument. So the angle is called the argument, and there's just the general argument, which can be any angle theta, but the principal argument is always going to be between -pi and pi. So notice how it's equal to pi and not equal to -pi. So if the answer would be you would never give the answer -pi, you would give the answer +pi. So that's kind of interesting. That covers all 4 quadrants, but it's negative angles in quadrants 3 and 4 and positive angles in quadrant 1 and 2. So when we're talking about the principal argument, we use a capital letter for our argument of z. And just be aware that the argument of 0, if z equals 0, is undefined. Now, one other note I want to tell you about this is what do we have to do when we figure out the angle? What did we talk about in our previous like 6.1 about this? What do we have to do? What else? What else? I'm writing it down. I'm helping you. Make sure you graph it to check the quadrant, correct? Because tangent is only going to give you a quadrant 1 or a quadrant 4 angle. And so if it's quadrant 2, then you're going to have to change your quadrant 4 angle to quadrant 2. And if it's quadrant 3, you're going to have to change your quadrant 1 angle to quadrant 3. But you only need to know how to do that if you actually graph it and pay attention to where the angle is and what quadrant it's in. All right.